Hey everybody, this is Mr. Bells again. Just wanted to let you know we're going to start right now with section 10.4, moving through the probability section. Hoping these are helping, hoping you're staying with this stuff, and let's give it a good shot right now. Okay? So here is what we're talking about. So section 10.4 deals with something called disjoint or overlapping events. So for instance, I could be talking in class and I might have a classroom of 25 students and I ask them, say, hey, how many of you participate in a spring sport? And maybe 15 of them say they participate in a spring sport. And then I say, how many of you participate in a winter sport? And there's 10 of them that participate in a winter sport. And how many of you participate in a fall sport? And maybe there's 12 of them that participate in the fall sport. Well, if I added all these up, you'd see that I get a total of 37, but there's only 25 students in the class. That means there must be something called overlap. There must be some students in this class that fall into multiple categories, and that's what we're going to look at, because when we're trying to do probabilities, I can't say, well, what's the probability of somebody participating in any one of these sports and say that it's 37 out of 25, because that's over 100% and that's impossible. Okay? So what are some of these key things? So disjoint, right here, this word disjoint, means there is no overlap. It means that if you're in one category, you can't be in the other category. So like if I said, what grade do you happen to be in? Well, you can be a freshman, or you can be a sophomore, you could be a junior, you could be a senior, but you should not be in both of those categories. Okay? So are we good on that? So some of the questions, like the first question says, which question is different? So how many outcomes are in the intersection of A and B? And then this one right here says how many outcomes are in the union of A and B. Well, intersection and union are two key words that either make this question really tough or really easy, depending on if we understand what those words means. So when we say intersection, we're talking about this portion, that overlap section. Okay, so intersection, I'm going to put green around this word, and I'm going to do this one in red. Union means we're going to put them both together. So union would be all of it. So if you fall in either one of these categories. Okay, so hopefully that helps out for you. So intersection is the shared or the overlapping part. Union is the whole thing. So this first question says, how many outcomes are in the intersection of A and B? Well, that would be, of course, 2. And then it says, how many outcomes are shared by both A and B? Well, the shared part is technically the word intersection, so that would be 2. This bottom question, how many outcomes in B, right, there's 5 of them in B, are also in A? Oh, well, there's 2 of them that are also in A. And then this one says, how many outcomes are in the union of A and B? Union means everything. So we count them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of them. So which one's not the same? Well, that, of course, would be this one right here. So there's questions that go with it, but hopefully that makes sense to you based on those problems. Okay? So that's what your first question looks like in that section, and hopefully a little bit of understanding as to why it does what it does. So this next thing, there's going to be some funky notation occasionally. And it says events A and B are disjoint. Disjoint means there is no overlap. No overlap. So if I'm trying to find the probability of A or B, that's the same thing as saying the union. So A or B means if I was trying to go, well, let me know, raise your hands if you're a sophomore or you're a junior. Well, we don't want sophomores and juniors because there's nobody in that category, but sophomores or juniors means that I want all the sophomores to raise their hand, all the juniors to raise their hand. Okay? So this one says events A and B are disjoint, which means there's no overlap, so I don't have to worry about somebody being in both categories. And I want to find the union. I want to find the probability of both of those occurring. Well, if the probability of it being an A is 0.55 and the probability of being a B is 0.22, then we know that the probability of, and I'm going to write this down even though A or B, probability of A or B is equal to the probability of A plus the probability of B minus the probability of B and A, which this is the overlap. And on this particular problem, since there's no overlap, I don't have to subtract anything, so I just have to add those two things together. And look at that, I'm going to give you that answer right there, it's 0.75. But hopefully you have the understanding for that. And again, the understanding is what's going to help you do the rest of these problems. So exercise 7 says your dart is equally likely to hit any point inside the board shown. You throw a dart and pop a balloon, so a balloon definitely pops. What's the probability that the balloon is red or blue? Well, unfortunately for us right now, this is printed in black and white. So I guess the easy thing to ask for you is, I'm going to ask, is there any overlap? Is there any red and blue balloons? So multicolor ones. I don't have it in front of me right now, but I'm going to assume no, which means these things are disjoint, which means I don't have to worry about the overlap. So then the probability of getting a red or a blue is simply the sum of the reds with the sum of the blues divided by the total number of balloons. I'll let you fill that one in. Okay? So here we go. This next one, exercise 9. It says you're performing an experiment to determine how well plants grow. Let me move this right into here. Under different light sources of the 30 plants in this experiment, so inside this big box, we're going to try and do a little chart right here. Inside this big box, there are 30 total plants. And it says of the 30 plants in the experiment, 12 receive visible lights. So I'll put this here. This is visible light. And then 15 receive ultraviolet light and 6 receive both. Oh, both. E. There's both, and there's overlap. 6 of them get overlapped. This is ultraviolet. Ultraviolet. Visible light. Ultraviolet light. 6 of them receive both. And it says 12 receive visible light. So if there's 6 right here, then how many go there? And if ultraviolet light, if there are 15 inside this and 6 of them right here, then how of them go there? And you should be able to go, well, if there's 12 here and this is 6, then this must be 6, right? And if there are 15 here and this is 6, then this is 9. So the union of this is 6 plus 6 is 12 plus 9 is 21. But there's supposed to be 30 in this entire thing, and I'm only counting 21, which means there are 9 out here that are getting some other form of light besides visual light or ultraviolet light. Okay? Now that you have this little Venn diagram drawn, hopefully that makes sense and that you could work through some of these ones on your own. You could do this problem. Okay, so then answer that question. Next. This one says, describe the error. Back here. Zoom in on that for you, or focus in on that. It says, describe the error with this problem. It says, finding the probability of randomly drawing the given card from a standard deck of 52 playing cards. So we got a bunch of cards. And it says probability of getting a heart or a face card. Heart or a face card. And they said it's 13 out of 52 plus 12 out of 52. And it equals 25 out of 52. Well, that's true. That equation is true. But it says the problem's wrong. So that means something we did here must be wrong. So let's double check. So it says probability of a heart. Are there 13 hearts out of 52 cards in the deck? And that's check mark, yes. And then the next question says probability of a face card. Face cards are jacks, queens, and kings, and there are 4 suits: spades, hearts, diamonds, and clubs. So if there are 4 suits and 3 per suit, that's 12. Well, that's right. So then what's wrong with this equation? Well, this is what's wrong with this equation. There's some that are both. So we've included, like, say, the Queen of Hearts as a heart, but we've also included the Queen of Hearts as a face card. So we're counting it twice in this category. But there's not 2 Queen of Hearts. So now we have that same situation that we had when I said here about the sports. It can't have a probability greater than what it is, so there's some overlap in there. Okay? So hopefully that makes sense. So what do? We said that we always take the probability of A plus the probability of B minus the probability of A and B, which is the overlap, to equal the probability of A or B, which is the union. Okay? And sometimes there's overlap, sometimes there's not. So we got to subtract that amount out. So hopefully you can then, based on what I just drew here, you can figure out those ones right here and then answer what the correct amount should be. Okay, so number 12, it says the probability of a club or a 9, and it gives you the same thing again. It tells you that you do this plus this equals this, and it's wrong. It's wrong. So use what logic was that I gave you on the one before, right up here, to go ahead and answer that next question, and I believe that you can. Reminder again, just keep your calculator, your handy dandy calculator, ready. Know that if you need to, that this button right here, math, will change it to a fraction if you need to. And remember that I gave you access to graphing calculators on your Big Ideas website, so that you can just pull those up when you need to, when you're doing this. Good deal. So we're rolling through this stuff, and hopefully you're understanding some of the things that we're talking about. So I'm all the way down to number 13. It says you roll a 6-sided die, and event A, first thing, is you roll a 6. So what's the chances of rolling a 6? Well, there is a 1/6 on a normal standard die. And then on event B, you roll a prime number. Well, prime numbers are numbers that are only divisible by 1 in themselves, excluding 1. So 2, 3, 5, 7, 11, 13, 17, 19. I could do a whole bunch of them. But their only factors are 1 and themselves. So 2 is the only even one. So if I roll a prime number, you know that 2, 3, and 5 are prime numbers, right? So all you have to do is go, okay, to figure out the probability of this, is you go, is there any overlap, right? If I'm trying to find the union, is there any overlap? So in these 4 numbers, outcome A and outcome B, is there any overlap? And the answer is no. So then the probability of this succeeding is simply the probability of the first one plus the probability of the second one, right? Because there's no overlap. So what is the probability of A? Well, that's 1 out of 6. What is the probability of B? That is 3 out of 6, minus the probability of the overlap, A and B. And technically, they use that little symbol, it's an intersection of A intersect B, which is nothing, so minus nothing, because there is no overlap. So that would be 4/6, and of course we want to reduce it, and it's 2/3. So there's the answer to that one. Hopefully this makes sense again, and that'll take you to the next one. So the next one says you're going to roll a 6-sided die. Roll an odd number, roll a number less than 5. What's the probability of A or B? So exact same problem, and now I'm going to say you do it. You do it. I believe in you. Okay. So this next one says, exercise 15, says you've got a group of trees, group of 40 trees in a forest that are not growing properly, right? Group of 40 trees in a forest that are not growing properly. So you're going to do this, right? You're going to go, oh, yeah, that's one of these problems. And I know that inside this thing, there's a group of 40 of them. And it says a botanist determines that 34 of the trees have a disease or are being damaged by insects. So, okay. So the question is there any overlap? I don't know if there's any overlap in there. I know that inside this, that 18 of them are supposed to be in here, and I don't know how much is in this section, how much is in the overlap. And I know that 20 of them have to be in here, so I don't know how much is in here and how much is in the overlap. But I know that these three sections together are supposed to have 34. Okay? So there's 34 in the union. So if you do the probability of A plus the probability of B, right, minus the probability of their intersection, A and B, is supposed to equal the probability of A or B for the union. Okay? And I'm going to let you be able to put that stuff into here to be able to answer that question. Think about if there's 18 and 20 of them here, right? That makes how much in here, but we know there's only supposed to be 34, so some of those numbers we're counting twice. Okay, let's go to 20. 20 says, are events A and B disjoint events? Disjoint. Disjoint means what? Say it for me. Say it, say it. You can say it. No overlap. That they don't share anything in common. So I look at that and I go, hey, wait, look at this. Look at that dude right there. Or do that. It doesn't matter which one. So that is definitely some overlap going on there. So there's something that's in both A and in B. Maybe these are all the people that went to Annie's party. And maybe these are all the people that went to Bobby's party. And Bobby and Annie aren't necessarily friends, so there's not going to be a whole lot of overlap. But maybe this person right here, maybe this person, Tanya. Tanya went to both their parties. She's the only one that is friends with both Annie and Bobby. Again, we could have all kinds of different things with that. And hopefully that helps on some of this stuff. Good deal. So you just got to pick which one of those blanks down there is the one that makes the most sense. And look at that. That is 10-4. So again, summary again. Disjoint and overlapping events. What happens when probability of something occurs in both of those categories? We have keywords, intersections, shared space, unions, the whole thing. And that when we're doing probabilities, we don't want to count things that are in both categories. We don't want to have that overlap for it. Okay? And then besides that, we have this nice little formula right here that works for all of these problems. Probability of A or B equals probability A plus probability B minus probability of both of them occurring. And we know that this probability of B and A is simply called the intersection or the overlap. Okay? And the last thing we had was we made some Venn diagrams. And again, in class, we'd go through so much more of this stuff and you'd understand it so much better. And we do examples and all kinds of stuff. We're just trying to do what we can right now. So hopefully this is helpful for you. And that's it. So this is Mr. Bells saying take care and do good work. We will talk to you later. Okay?